All right, guys. Unit 3, Lesson 1, Investigation 2. Everything we've done so far has been in preparation for what we're going to do today. All right? So all that work that you guys have done with the distance formula, the midpoint formula, and the slope formula, that's been in preparation for what we're going to learn how to do today. Okay. Also, our review of the quadrilaterals. That was preparing us for today. All right? Because today what we're going to do is we are going to learn how to classify polygons that are formed by ordered pairs on a graph. Okay? We're going to focus mainly on quadrilaterals, which is what I mean by QLAT. Okay? Quadrilaterals got a ton of letters in it, and I'll probably put them in the wrong spots. All right? So quadrilaterals, QLAT, all right? And triangle, well, I can spell that one. That one's not too bad. Although sometimes I do write triangles. Should yell me. No one wants today? That's fine. All right, so what type of quadrilateral is JKLM? Okay. Now, it has 4 vertices, right? You guys remember vertices are ordered pairs? Right? These are vertices, aren't they? Right? If it has 4 vertices, how many sides does it have? 4! Makes sense. 4 vertices, 4 sides, right? Does that make sense? Okay. So, we want to figure out what kind of quadrilateral this is. So, what are some quadrilaterals it could be? What are some quadrilaterals that it could be? Square. What else? Rectangle. What else? Rhombus. What else? Kite. What else? Parallelogram. What else? Trapezoid. Square. Isosceles trapezoid. Just a quadrilateral. Right? Now, how are we going to tell the difference? Should I just make a picture of it and then just say, oh, it looks like this one? Yeah. Is that what I should do? Just make a picture and say it looks like this one? Yeah? Okay. Well, let's make a picture then. Let's see. Oh, let's build my markers. So here I have some graph paper. You guys would like some graph paper? There's some in the back. Do this. I don't want to make my graph paper smaller. Okay, so that should be enough. All right, so here are some graph paper. All right. Now on your notes, it doesn't have to be a perfect graph. It can just be just kind of one just drawn on there. It's fine. The reason why it doesn't have to be a perfect graph is because the way it looks is not how we're going to figure out what it is. All right. So I'm going to graph JKLM. All right, so then maybe you guys can tell me what it is. So J is at negative 5, 3. Where's negative 5, 3? Well, we go over 5. Up how many? 3. So this is point J. K is negative 4, 1. Right? L is negative 1, 3. And M is negative 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So now that's our figure. Let me get a glare. Does this help? No, you can't see it. All right. Dang it, I hate glare. All right. So that's our figure, JKLM, right? Are there any questions about it? Any questions? Okay. So now, how do I draw my figure? What should I do? What lines do I connect? What lines do I connect? J to what? J to K, right? Okay. K to L. L to M. M to J. So, what does that look like? The quadrilateral has 4 sides, right? What does it look like? Here, trapezoid, I hear kite. Okay. How can we be sure? What paper? That green paper we have, right? That lists all the quadrilaterals, right? Now, if I look at that green paper, it might tell me some information about how quadrilaterals are different, right? What is that information? How do I know they're different? What's different about them? What makes a parallelogram different than a square?
The angles and sides.
Sides. What about the sides?
Corresponding or
Not corresponding, opposite. I think is what you're looking for.
diagonal.
Are what? Parallel. If it's a parallelogram, opposite sides are parallel, right? Is that true for a kite? No. Okay. So how do I determine the sides are parallel? What do I use?
Isn't it a squared?
No. What do I use? Remember, guys, I said the things we've done so far, slope, distance, midpoint, that was all in preparation for today. So how can I determine the sides are parallel? Rise over run, what's that? Slope. What do I have to know about slope for lines to be parallel?
Same.
They should be the same, right? So one way I'm going to classify this quadrilateral is I'm going to calculate the slope of each line, right? Right? If I calculate the slope of the sides, I can figure out if sides are parallel, or there's another P word in there, perpendicular, right? Remember, the same slope means it's the sides are parallel, right? Negative reciprocal slope means that they are perpendicular. Why do I feel like we forgot this already? You shouldn't have. We did it like 4 days ago.
That's hard.
We did it 4 days ago. All right. So slope is how we're going to figure out sides are parallel or perpendicular. Right? Have we all done slope before? Yeah. Now, so slope's going to figure out parallel or perpendicular. But what will make it something from, like, let's say I have a kite and a rhombus. How do I know they're different? Sure. How do I know a kite and a rhombus are different?
Different size.
Different size. What do you mean by different size?
Different shape. Angles.
Okay, not angles. You're on distance. What about distance?
Like the opposites.
What?
I don't know.
You don't know. What about distance, Jamara?
Wait, what are we comparing?
If I had a rhombus or a kite, let's say long thought this was a rhombus, right? How can we be sure if it's a rhombus or not? What's true about a rhombus? All the sides are
Same.
the same length, right? How do I find the lengths of the sides? What? Measure it. So I'm going to take out my ruler. No, we're not going to do that. We just learned it yesterday. How do I find the length of the side? No? Oh my goodness.
Isn't it point A and box? Isn't it point A and point B?
We do not use the boxes. Guys, your worksheet was just you guys calculating this. Distance. You found the distance between 2 points, didn't we? Yes, I'm talking about that. It's the length of the sides, right? Okay. So we're going to use the distance formula to figure out side length. Right? If two sides have the same length, that means their distances are the same. What? Okay.
I still wrong.
Sure. Hopefully it's only a short meeting.
I'll have him back when?
I don't know. Long way. Oh, gotcha. When? All right. Any questions? Okay. Guys, I know you know slope, parallel, and perpendicular. We did a whole worksheet on that was due on Monday. Right? I know you know that. Okay? Distance formula. We did that yesterday. Okay? So, we should know this stuff. Okay? If you can't use those equations, slope, distance, and midpoint, if you cannot do those, then you are behind. Okay? Then you need to come see me at lunch or before school. Okay? Or after school. Alright? Or watch the other videos I've made about slope, distance, and midpoint. You need to do something. Just sitting here and saying, oh, I don't get it, I'll just get it eventually. It doesn't happen. You don't get something for nothing. You have to do some mental work. Okay? You have to produce some mental sweat. Alright? Some of us haven't even broke a sweat in this class yet. Alright? And that's obvious by what we get in the grades. Alright? Yes, it is recording. Okay? You guys need to be doing some work outside of class. You need to be doing something else.
So what was the question?
Okay.
I'm trying.
Good. Keep trying. Okay, so we're trying to figure out what type of quadrilateral JKLM is, right? So to do this, you need to use the slope equation to figure out sides are parallel or perpendicular, right? And the distance formula to figure out the sides of the same length. Right. Now, how many sides are there? 4 sides. So how many times are we going to do each equation? Four times. Okay. You have to do each equation 4 times. Because if I want to figure out if JK is parallel to LM, I got to calculate the slope of each, right? If I want to figure out that these two are parallel, I got to figure out the slope, don't I? Well, these two got to figure out the slope, right? If I want to know if these sides are the same length, I got to use the slope, or use the distance formula, right? So we need to calculate the slope and the distance of each side of that figure. Nope. Midpoint's more for the diagonals. Nope. Because if I do JK and LM, that's just these sides. They're going to do JM and KL, which is these sides. So okay. Slope, 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 slope. 1, 2, 3, 4. Distance, 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 distance. 4 times. And just get it 4 times each. All right. Any questions? I know you're thinking, man, that's a lot of calculations. But it's the same thing over and over again. It's easy. Once you got it once, you got it forever. All right? All right, any questions before we get going on this? Any questions? Okay. Some things that I found to help us when we're working on problems like this. If we line our points up so all the x's and y's are in the same spot. If we draw a line down the middle, then I know all my x's are on which side? The left. All my y's are on which side? The right. Okay? And I like to draw a line like this, because then this helps me separate the points. Right? Because if I rename all these x1, x2, each time it's going to get confusing. But if I look and say, okay, I'm figuring out the length of jk, or the slope of jk, then I'm going to have k be number 2, and j be number 1, and then I know where to plug in my x's and my y's. Okay, does that make sense? You guys want to try one together? Okay. Let's try JK. And I'm not JK. Sorry, I've been waiting to say that all hour. You're LOLing? Oh, dropped my markers. Okay. So remember J was what again? Sure wrote this down earlier. -5, 3, right? M was -4, 5. L was -1, 3. And K was -4, 1. Right? You guys want to do slope or distance first? Slope? Okay, I'll do slope first. Why slope? Simpler? Okay, start with the easier one. Alright. So we're going to need to figure out the slope of JK, right? The slope of LM, the slope of MJ, the slope of LK. Now I like to go in order, so I'm going to erase these and go LK, and then LM, sorry, KL, LM, MJ. So I'm going in order. J to K, K to L, L to M, M to J. Okay, see that? You can do them in any order you want, Joanna. But that's the way I like to do them. Okay. So now I got to figure out the slope, right? Right? So our slope equation is y2 minus y1 over minus x1. Good. So I'm going JK. Okay. The way it's set up, K is probably my point 2. K is my point 2, and J is my point 1. So K is 0.2. What's the y value of K? What's the y value of K? 1. What's the y value of J? 3. What's the x value of K?
-4.
What's the what's the x value of J? -5. So this is how we figure out the slope. 1 minus 3 over -4 minus -5. What's 1 minus 3? -2. What's -4 minus -5? 1. So my slope is -2 over 1, which is -2. Does that make sense? Does that make sense? Okay. Now, how long do you think it's going to take you to calculate one slope? Good guess. One slope. How many minutes? 1? Okay. I'll triple that. Right? You guys have 3 minutes to calculate one slope. Okay? Kendra's row, you guys have KL. Okay? Jamira's row, and you guys have KL. Or sorry, LM. Okay? Kendra, Jamira, and then Faith's row, you guys have MJ. Alright, you guys got me? Okay? If you get done early, then try the other ones. Okay, so you guys got MJ first, you guys have LM, you guys have KL. Okay? Can you guys do that? Find the slope of MJ, Yovani. Okay. Give it a shot.
What we're doing? Is this?
Just the slope.
I know, but
Write it out. Right? I'm going LM.
I did. But
LM.
we're doing y2 minus y1, right?
Y2 minus Y1.
Then
If you go the other way, it's fine. Okay? If you do L minus M, that's fine. Just do it on top and on bottom. Okay? Straight. No, don't do it in your head. Do it on the paper.
did you divide?
You can divide them out if you want to. You can leave them as simplified fractions if you want to. Either one works.
Can't get a decimal.
If you do decimal, it's fine. But if you want a fraction, hit math, then frac. Hit math, enter, enter.
So we can see what that's a fraction.
Yep, fractions are fine.
Ah.
Right? I think most of us are earlier slopes.
You probably just did
So most of us are earlier slopes. Anybody need more time on our slope? You good? Okay, KL. Someone in Kendra's row. Tell me what to do. Kendra, Louise, China, who wants to tell me? Okay, Luis, you're smiling. I'll let you go. What's the top look like?
3 minus 1.
3 minus 1. So the 3 from here, right? The 1 from there. Good. 3 minus 1 over?
Negative 1 minus negative 4.
Good. Negative 1 minus negative 4. What'd you get, Kendra, when you did that?
I put them in the wrong spot.
So did you have 1 minus 3
Yeah, like they're upside down.
and negative 4 minus negative 1? So you just had these in front?
Yeah, but
Oh, and upside down?
yeah.
Oh, okay. China, what'd you get? 2/3. So you get 2 over 3? Okay. That's correct. Now, if you're done with Kendra, what I thought Kendra was saying, where she said she put her 1 in front of the 3, Jordan.
Yeah.
Go with me. The 1 in front of the 3, the 4 in front of the negative 1, you still get the same answer.
Correct.
Okay. So you got 3/2, didn't you?
No, I got like negative 3 over
Okay. All right, let me do some subtraction here too. All right, you see what you need to do now? All right, LM. Andrea, what'd you plug in?
3 minus 5.
3 minus 5. So 3 from here, 5 from there. So 3 minus 5.
Negative 1 minus negative 4.
Okay, negative 1 minus negative 4. So negative 1 minus negative 4. So you called L.2 and M.1. That's fine. If you do it the other way, so if you had 5 minus 3 and negative 4 minus negative 1, you'll get the same answer. Okay? Andrea, what did I end up with?
I got negative 2 over 3.
Negative 2 over 3? Okay. Anybody else in that row that we got? Negative 2 over 3? Yeah, Alyssa's that we got? All right, MJ. Tony, what'd you write down?
5 minus 3.
5 minus 3.
Negative.
Okay, so this 5?
Yeah.
Right, minus that 3?
Yeah.
So is it negative or positive? They're all positive, right? Because remember that our x, here's our axes, right? X, Y. All the y's are positive. Okay. So 5 minus 3 over?
Negative 5 minus positive.
Okay. 5 minus 3, right? You're calling this your second point, right? So which one has to go first, the negative 4 or the negative 5? The negative 4 has to go first. So negative 4 minus negative 5. Okay? We in agreement, Ro?
Of course.
Yeah? 5 minus 3 is what?
2.
2. Negative 4 minus negative 5 is what?
1.
Positive 1.
2.
2. So there I have all of my slopes. Correct?
Yep.
Are any of the sides parallel?
Yes.
Which ones?
K, L, and
Which one?
L. K, L, and L.
K, L, and LM, they're parallel? They're the same slope? No. They're close, but they're not, aren't they? One's positive, one's negative. Which one? JK and MJ, they're close, right? But one's positive, one's negative. Are any sides perpendicular?
Yeah. You like K, L, and L.
Which ones are perpendicular?
KO and LM.
These aren't perpendicular. They're negative, but did they flip?
Yeah.
Yeah. Oh no.
No, this had negative 3 halves, right? So they're not perpendicular. Okay? Does that make sense?
Yep.
Any questions?
Nope.
So there's no parallel and no perpendicular. Which one? JK and MJ? It'd be negative 2 and 1/2, wouldn't it? Okay. So no parallel, no perpendicular. Right? That's fine. Okay. It's just a figure that has no parallels and no perpendicular. So it can't be a rectangle, right? It cannot be a square. It cannot be a parallelogram. Well, it can't be a trapezoid because trapezoid has some parallel, don't they? Opposite sides are parallel on trapezoid, right? Okay. So there's only 2 things left.
Square.
Nope. Square has perpendiculars, right?
Right?
Can be a kite or just a quadrilateral. Okay. So to be completely sure, we now have to figure out the lengths. Okay? To find the lengths, what formula are we going to use? The distance formula. So the length of the sides, right? The length of the sides, we're going to use the distance formula. Y2 minus Y1 squared plus X2 minus X1. Oh, that's not bad. X2 minus X1 squared. Right? That's our distance formula? Oh, sorry. Right, guys?
Yeah.
Yeah. So, we have to do the distance of all of them or just a couple? All. So we have to do JK, JL, LM, MJ. Okay. Now let me show you a quick little trick. Okay. Well, the only reason it works long is because we've already calculated Y2 minus Y1, haven't we?
Yeah.
We've already calculated X2 minus X1, haven't we? Because if we look, this is Y2 minus Y1, isn't it?
Yep.
This is X2 minus X1, isn't it? So I can take this and plug it in right here. Okay, does that make sense?
Yeah.
Okay, and I can take this and put it in there. So it saves me the time of looking up which one's X and Y again. Right? So for this first one, JK, we have 1 minus 3 squared plus negative 4 minus negative 5 squared, right? Correct? We know this, 1 minus 3 is what? Negative 2. So negative 2 squared plus 1 squared. If I square a negative, what do I get? Positive, so I have 4 plus 1. Right? 4 plus 1. What's the square root of 5? Square root of 5. You guys get calculators.
25.
It's not, that's 5 squared. Square root of 5. Not 2.5, that's half of 5. What is it? 2.2. So that means JK is 2.2 units long. Okay? So this side right here is 2.2. Right? Does that make sense?
Yeah.
Okay. Can you guys all do your sides?
No.
So Kendra's got KL, Jamira has LM, Faith says MJ. You guys got that? Can you do it? 3 minutes again?
What do we have? Owens?
Give LM. Same way last time. The right answer? Okay. The game's not very fun with 1 cup, is it? Oh, the cup's on.
Oh, that one was funny.
Alright, sounds like we're done. Okay, so KL. Kendra, I'll give you a second chance. What'd you get?
3. -1 minus -4.
And what did it equal?
The second part of that?
What was the final answer?
3.6.
2.6?
3.
3.6. You guys agree? Okay. LM. Let's see, Jamira, what'd you get?
I got 3 minus 5 squared
3 minus 5 squared. Rocket shot. Pick out,
plus
please.
-1 minus -4 squared.
Okay.
And then I got 3.6.
3.6.
Yeah.
You guys agree? Andre, agree? Melissa, Rebecca, Rock? Right. MJ. Whitney, what'd you get? Yep. Okay, so you flip the order when you do your slope. You do a different order. Okay, that's fine. Works out. Okay, so what can we say about JK, KL, LM, and MJ? Anybody know?
KL and LM are parallel.
Not parallel. Close though. Over here we did 5 minus 3.
They have the same.
She did 3 minus 5. That's okay. So what'd you say, Jamar? KL and LM are the same distance, right? So if two sides are the same distance, that means these two sides are
Quadlaterals.
the C word,
Corresponding.
congruent, right? So those two sides are congruent. Okay, good. JK and MJ are also congruent. Right? So what that means is when I draw my figure, you guys just said that JK and MJ were congruent, right? Right? And ML and KL were congruent, right? Okay. Go neat. So, which figure has adjacent sides congruent?
Oh,
A kite. Adjacent means next to, right? So we know that JKLM is a kite because, Jordan, stop talking, adjacent sides are congruent. Okay. Now I know what you're thinking? That's a lot of work.
Yep.
But it was the same thing 4 times. You did 2 different things 4 times. That's all you did. You did slope 4 times, distance 4 times.
But then someone said it was a kite, like without a bunch of food work.
Right. They said it was a kite, but that was just a guess. Okay? If I just look at the picture and say it's a kite, that's a guess. But if I say it's a kite because opposite side or adjacent sides are congruent, now I've proven it. Okay? That whole process we just did, we proved it was a kite. Okay? Just saying it is not enough. You have to show it and prove it. Okay. Any questions?
Are we done?
Are we done?
Yes.
No.